Have you ever noticed that your detergent feels warm when you mix it with water? Is it magic? Nope, it's science. When you add detergent, especially the powdered kind, to water, you're witnessing an exothermic reaction. This means heat is released during the process. Let me explain. Detergents often contain compounds like sodium carbonate or sodium percarbonate. When these dissolve in water, they undergo a chemical reaction that releases energy in the form of heat. For example, sodium carbonate, also known as washing soda, reacts with water molecules. The energy released during this reaction increases the water's temperature slightly. This heat is not just a cool, or should I say warm, phenomenon. It helps the detergent work better by speeding up the breakdown of dirt and stains. But be careful. If the reaction feels too hot, it might be because you're using too much detergent or mixing it in a concentrated form. Always follow the instructions on the package. Now you know! The warmth you feel is a little burst of science working hard to clean your clothes. Next time, you'll know exactly what's happening in that bubbly magic. If you enjoyed learning this cleaning science secret, hit the like button and subscribe for more everyday science wonders. For the second science fact, I will tell you why boiling water creates bubbles. What's happening inside the pot that makes it look like a bubbling cauldron of magic? It's not magic, it's science. Let's break it down. Water is made up of tiny molecules that are constantly moving. At room temperature, these molecules are tightly packed in the liquid state, but when we heat the water, things change. When you heat water, the energy from the heat makes the molecules move faster and faster. As the temperature rises, some of these molecules gain enough energy to break free from their liquid state and turn into gas. This gas is water vapor, and it starts forming tiny bubbles at the bottom of the pot, where the heat is strongest. As the water gets even hotter, more bubbles form. They rise to the surface and burst, releasing the water vapor into the air. This is what we see as steam. The bubbling really takes off when the water reaches its boiling point, 100 degrees Celsius or 212 degrees Fahrenheit at sea level. At this point, the entire water is transitioning from liquid to gas. Fun fact, if you're at a higher altitude, like on a mountain, water boils at a lower temperature because of reduced air pressure. And remember, boiling water is hot and dangerous. Handle it carefully to avoid burns. So the next time you see water boiling, you'll know, it's just science turning liquid into gas, one bubble at a time. Pretty cool, right? If you enjoyed this little science bubble, hit like and subscribe for more fascinating everyday science stories. Let's know the third one. Here's a mind-boggling question. How can hot water freeze faster than cold water? It sounds impossible, right? But it's a real phenomenon called the Mpemba Effect. The Mpemba Effect is named after Erasto Mpemba, a Tanzanian student who noticed this puzzling behavior in the 1960s. But why does it happen? Let's dive into the science. In hot water, the molecules are moving faster and are more spread out compared to cold water, where the molecules are more tightly packed and moving slower. But when both are placed in a freezer, several factors come into play. First, evaporation. Hot water loses more heat through evaporation because it's closer to its boiling point. As water evaporates, the remaining liquid has less mass to freeze, speeding up the process. Next, convection currents. In hot water, these currents are more vigorous, which helps distribute heat more evenly, allowing it to cool faster overall. Then there's supercooling. Cold water is more likely to cool below its freezing point without turning into ice, while hot water starts forming ice crystals sooner because of how its temperature drops. Fun fact. Scientists are still debating the exact reasons behind the Mpemba effect, and it might involve a combination of these factors and more. While this is a fascinating phenomenon, don't try it with glass containers. They might crack due to the temperature difference. So, the next time someone tells you hot water freezes faster than cold, you can wow them with the Mpemba effect and the strange, wonderful world of science. If you enjoyed this icy mystery, hit like and subscribe for more cool science facts. Ever wondered why sprinkling salt on ice makes it melt faster? It's not magic, it's chemistry at work. To understand this, we need to talk about the freezing point of water. Normally, pure water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. But when you add salt, things get interesting. When salt is sprinkled on ice, it dissolves into sodium and chloride ions. These ions interfere with the water molecule's ability to bond and form a solid structure. This interference lowers the freezing point of water, meaning the ice can't stay solid at 0 degrees anymore. Instead, it starts melting even at sub-zero temperatures. That's why salt is used on icy roads and sidewalks in winter. It helps melt the ice and prevents more from forming. But there's a catch. Salt becomes less effective when temperatures drop too low, because even salty water can freeze if it gets cold enough. Fun fact. Other substances like calcium chloride can melt ice at even lower temperatures than regular salt. And remember, while salt is great for melting ice, it can be harsh on plants and metal surfaces, so use it wisely. So next time you see salt melting ice, you'll know it's all about science lowering the freezing point. Cool, right? Have you ever noticed that sugar dissolves faster in hot water than in cold? Why does temperature make such a big difference? Let's find out. It all starts with water molecules. In cold water, these molecules move slowly, but when water is heated, the molecules gain energy and start moving much faster. When you add sugar to water, the moving water molecules collide with the sugar crystals. These collisions break the bonds holding the sugar together and help disperse the sugar molecules throughout the water. In hot water, the faster-moving molecules collide with the sugar more frequently, and with greater force, speeding up the dissolution process. Not only that, but higher temperatures increase the solubility of sugar, meaning more sugar can dissolve in hot water than in cold. Fun fact, this is why your tea or coffee tastes sweeter when stirred with hot water. It's easier to dissolve all that sugar goodness. And remember, hot water can be dangerous, so always handle it with care when stirring or pouring. So, the next time you stir sugar into hot water, you'll know, it's the fast-moving water molecules working their magic.